Welcome back. Today we're going to be talking about data analysis. So let's go ahead and take a look at some important information. So here we're going to be talking about sampling, population, a large group of something you want to collect data on, so that includes everything that you're looking at. A sample is a subset or a smaller group of that population. Sampling is the process of selecting a subset from a larger group of that population to study and draw conclusions about the entire population. It's a way to make observations and inferences about a larger group without having to analyze every single individual or element within that group. And sampling should always be random. So let's put this in practice with example A. So here in example A, FCPS wants to know how long students spend doing math homework, which is a method. Which method should they use to answer this question? So we're going to try and figure out which one of these ways they should pick in order to figure out the answer to their question. So example A, they could ask one student from one school. That wouldn't provide them a large sample size there. You'd have only one individual. You wouldn't get a lot of information. B says randomly sampling students from one school of the same grade. So again, larger than one person, but they're from one school and they're all in the same grade. So you're only testing that one grade and that one class's math homework. You're not testing across the county and you're not crossing at different grade levels. Randomly selecting students from multiple schools of the same grade. So again, now you're doing a little bit better because you've included more schools, but you're still only hitting that one grade. So if you're doing grade 7, for example, you're only checking how many people do homework in 7th grade. And then the last one, randomly selecting students from multiple schools for multiple grades, is our correct answer because again, we're going to be selecting from multiple schools. So we're getting across the county and we're selecting multiple grades. So we're getting algebra, math 7, pre-algebra, etc. Now let's take a look at some more important information. So now we're going to discuss outliers. Outliers is a data point that significantly differs from other observations in the data set. So for example, here we can see that our data is lined up from least to greatest, and we see that 31 is way outside of the next closest number, which is 51, and then 174 is way higher than the next set of data, which is 118. Outliers can significantly impact the data and will change the aspects of our box plot. So let's see that in practice. So here in example B, it says a box plot was made of the SEC period exam scores. What would change if we were to include in the box the outlier in the box? So taking a look at our box plot, we can see that outlier is all the way down at around 23%. So that person did not do very well on their box plot exam, but the majority of the class scored between 60 and 100. So we want to make sure that we're not including that person because it's going to upset the data. So what things will change? A lot of things will change, right? If we include a 22% in a data range that's between 50 and 100, it's really going to mess with our data. So a lot of things will change, but we want to know which things will change the most. And the things that will change the most are going to be the mean and the range, because if we had 22% into the average of all of our scores, it's going to significantly lower the average score of the test. For example, if everybody were to take a math test and then somebody didn't, and they got a 0%, that 0 is going to way affect the average. Same thing with the range. If I subtract 100 minus 55, that gives me a range of all of the scores. But if I include that 22%, that range is going to double almost because I've now taken that much wider group apart. So we want to remove outliers when possible so that we get better looks at our data. Now let's take a look at some more important information. So now we're going to be talking about misleading graphs. Misleading graph is a graph that distorts or misrepresents data, potentially leading to incorrect interpretation or conclusions. So why would somebody create a misleading graph? Like why would somebody take the data and make it so that it looks a little misleading so that you buy their point of view? Often data is misleading because the person using the data wants to convince you of their point of view. So they're trying to present the data to you in a way that makes you agree with them, as opposed to looking at the data and making your own conclusions. The idea is that you will come to their conclusion as opposed to your own conclusion. So let's take a look at a few examples of this. So here in example C, we're going to be talking about the omitting the baseline. So on the left-hand side, we've got the misleading graph, and that graph has truncated the axis, exaggerating the difference in the parties. So they took off the bottom of the baseline there, and it appears the Liberal Party members are in favor of the bill more than the Labor Party by almost double because of the way that they've taken out the baseline. If you were to make it more accurate, like the right-hand side, the graph has a vertical axis starting at the 0 baseline as opposed to 68, which is the one that's randomly starting at a number they chose on the left. Okay, the zero baseline shows that there is only a small difference in the proportion in the favor of the bill, because again, you started at 0 as opposed to 68, some number that you randomly chose. But if you wanted to show that your party was doing a better job, then you would use the data on the left because you just randomly started at a number that made yours look better. Now let's take a look at the next example. So another way that people use misleading data is to have an irregular scale. So the misleading data is on the left, and we're talking about global average temperature, and they say the range of values shown on the vertical axis is disproportionate to the data. So you can see the years are going from 1880 to 2016, okay, but they're jumping this temperature by 5 degrees each time on the left. This makes it appear as though the temperature is constant, so no variation or overall increased trend because, temperature globally hasn't gone up a massive amount or 5-degree swing over time, or we would, significantly experience that. But on the right-hand side, the accurate of the range value shown in the vertical axis is proportionate to the data, so that we can see now that it's up by a half a degree each time, and we can see that it's trending higher every time because the correct axis is being used. So the misleading data is used on the left-hand side to show you there really hasn't been much change. But if we actually use the correct scale, we can see that there has been a wide variation in the temperature over time. That brings us to the end of this example. It also brings us to the end of this set of notes. If you like this video, go ahead and say thumbs up. If you love this video, go ahead and say sub, and we will catch you in the next one.